And welcome today to Math 7, Chapter 4, Section 3, Zero and Negative Exponents. This begins on page 206 in your math book. And so today we're going to talk about zero and negative exponents. So zero, a very interesting little number. What happens when we have an exponent of zero? So here we see a rule, a to the zero, what does that equal? And an actual example, 8 to the 0. So before we reveal what the exponent 0 does to a base number like 8 or like a, let's take a look at this example on the right. So an exponent of 0, how do we get an exponent of 0? As we begin to use the properties of multiplication with exponents, we'll see this more clearly, but because you're such a bright class, I think we can go ahead and take a look at that now. What happens if we have a number being divided by itself? You have some experience with this. What do you think happens? Tell your neighbor, what happens when you have a number divided by itself? Good. You, I'm sure, know that that number equals 1. So let's take a look at what happens between 4 squared divided by 4 squared. We could write 4 squared divided by 4 squared a different way. We could write that as you know, 16 over 16, which of course equals 1. We could also write it this way, which is very tricky, and you'll learn this as we move forward. But we could write this as 4 squared minus this exponent. So we could move the denominator, which has the same base as the numerator, they both have the base of 4. Because they do, we can say that the two exponents are being subtracted by division. So what is 2 minus 2? 2 minus 2 is 0, right? So this is a small proof to show that if you have an exponent of 0, it's the same as dividing a number by itself. So whenever you have an exponent of 0, that the value of that expression equals not the number one mistake, which would be, what do you think the number one mistake is? You're right, not 0, it would be 1. Any number raised to the 0 is 1. So as a rule, we can say a to the 0 equals 1, or in this example, 8 to the 0 equals 1. You got it. So be careful of that number one error. It's a pretty common mistake. Let's see what happens now with a negative exponent. So if I have a negative exponent, we saw that negative 2 in that example. That expression then, that entire expression, is really 1 over a to the n. So it's as though we're taking a reciprocal. It is the reciprocal of a to the n, 1 over a to the n. So if we have 3 to the negative 4th, the negative does not make this whole expression negative at all. Instead, it says that 3 to the 4th is really needs to move to the inverse location. This equals 1 over 3 to the 4th. Notice the negative is now gone. This is not a negative fraction, is it? This is just 1 over 3 to the 4th. And 3 to the 4th would be 4 3s. 3 times 3 times 3 times 3. 3 times 3 is 9, so 9 times 9 is 81. So this equals 1/81. 1 over 81. So the converse of that would be to take a number that does not have a negative exponent. You know, we could move that entire expression to the inverse location. We could move it to the denominator as long as we change the exponent to the opposite, right? So a to the n could also be written as 1 over a to the negative n. Very good. So let's try that with a real expression, a real number. 4 to the 6th equals 1 over Good. 4 to the negative 6. Good. Okay, let's try to use 0 and negative exponents. So here's a question. Pause the video and see if you can answer this question. Are 5 to the negative 4th and 1 over 5 to the negative 4th equivalent values? Okay, 5 to the negative 4th, as you know, that simply equals, let's see if I can write this with a pen, 1 over 5 to the 4th. Okay, so we move the base and the exponent to the inverse location, and now the negative drops off. We have 1 over 5 to the 4th. This expression, the second expression, is different, isn't it? We can change that expression too by moving this term to the inverse location and moving the negative. So we end up with 5 to the 4th over 1, right? Over 1. Sometimes we don't even show that. We allow that to stay invisible. So are these equal values? No, they are not. So we strike out the equal sign. These are not equivalent. They're actually reciprocals, aren't they? Let's find the value of expressions written with negative exponents. 7 to the negative 2nd. See what you can do. So 7 to the negative 2nd could be written as 1 over 7 to the 2nd, right? And now we wouldn't leave this number in exponential form. We would actually rewrite it as 1 over, what is 7 squared, or 7 times 7? It is 49. Good. So 1 over 49. Example 2. The quantity, negative 2, the entire quantity in parentheses, to the negative 5th. Well, let's just start with this negative 5 exponent. The negative would cause the entire quantity negative 2, to go to the inverse location, right? So we go to the denominator, where we now lose the negative in the exponent because we've moved it, right? So it's down below. Good. And notice the entire quantity is happening how many times? 5 times. Good. So, and it's negative. So, negative 2 times negative 2, 4. 4 times negative 2, negative 8. Negative 8 times negative 2, positive 16. Positive 16 times negative 2, negative 32. Okay, we could put the negative in the denominator, but usually the negative is brought up to the numerator to show that the entire fraction is negative. So that's what we'll do. Okay, how about negative 6, the quantity, negative 6 to the 0. And before you say the answer, can you tell me the number 1 wrong answer? You got it. The number 1 wrong answer is 0. Good. So the correct answer is 1. Good. And finally, we have, a fraction. This is more complex. This is, the quantity 1/3 to the negative 2. So what we can do is that negative 2 is affecting both the 1 to the negative 2 and the 3 to the negative 2. Okay, so we can rewrite this moving each of the terms to their inverse location. So we would move the 3 to the numerator, 3, and it is still being squared, but now we've lost the negative. And the 1 moves to the denominator, which is being squared. Okay, 3 squared, 3 times 3 is 9, good. And then 9 over 1 squared is just 1, so our answer is 9. 9 over 1 is 1. Okay, we may be asked to evaluate algebraic expressions that have negative exponents. So that means to put them into simplest form, simplify them. And when we simplify them, we need to know this rule. There may be no negative exponents in your simplified answer. So, number 10, 3x to the negative fourth. There's a negative exponent. But what is that exponent impacting? What value is it affecting? Is it affecting 3x or just the x? You got it if you said just the x, because there is no parentheses around 3x. This exponent is only affecting the x. So we could rewrite this as 3. Now the x is to the negative fourth, so let's move that to the denominator, x to the fourth, and now we can lose the negative in front of that exponent. When you move the term to the inverse location, you lose the exponent, the negative part of the exponent. Okay, let's try it again. We have 7x to the 0. So once again, only the x is being impacted by the exponent. So what is any number to the 0? Good. This is really saying 7 times 1. Good. So when we simplify that, we have the answer 7. Very good. Let's try number 12. Ooh, this is tricky. We now have a term in the denominator that has a negative 1 exponent. So the numerator doesn't have a negative exponent. So we will leave the 3 where it is, 3, but the denominator moves to the inverse location. It moves up, and we have x to the first, and x to the first is the same as having 3 times x. So simplest form would be less writing, so we write 3x. Good. And finally, one more. Try that, see what you can do. Good. Once again, we have 9 with no negative exponent, so it stays where it is. But the n to the negative 3 in the denominator has a, as you can see, a negative exponent. So we're going to move that term to the numerator and drop the negative. And we keep the exponent, though, the value of 3, 9n to the third. Good job. So again, the negative does not change the fraction to a negative fraction. Instead, it just takes that term to the inverse, the other location. That's what. Let's try one other example, and then you're on your way to your assignment. We have a fraction, 3/4, the whole quantity raised to the negative second. So as we did in that other fraction, we could rewrite this. That negative 2 is affecting both of the terms in this quantity. So we could rewrite this as 3 to the negative 2 over 4 to the negative 2. Right? Which means that both terms are going to move to their inverse location. The 3 will move down, the 4 will move up, and they'll carry that little exponent with them, won't they? So we can call this 4 to the second over 3 to the second. Good. And yes, we know the value of 4 to the second. 4 to the second is 4 times 4, 16. 16 over 3 squared, which is 9. And that's improper, so let's change it to a mixed number. 9 goes into 16 once, and we have a remainder of 7, which is still being divided by 9. Excellent. And now you may go ahead and begin your assignment and have fun. Good luck. It shouldn't take you long. Great.